We will solve this system of differential equation using elimination. Either eliminate x and then solve for y, or eliminate y and solve for x. But first, I will rewrite the equation as follows. I will write x prime as dx, and I move the 2x and the y to one side. Do the same thing for the other equation, but instead of writing dy, I put x and y in order. The negative 6x will become 16x on the left hand side, and then derivative of y, and then minus 2y equal to 0. So that's our system of equation. Right. Now we so this system of equation. First, I will factor out an x, and we have d minus 2x plus y equal to 0. And then the other equation, we have 16x plus d minus 2 y equal to 0. On this problem, either we eliminate x and solve for y, and eliminate y and solve for x. But I think the way the answer looks, we will eliminate x and then solve for y. So just keep this in mind. Eliminate x and then solve for y. To eliminate x, but we multiply so that the coefficient of x will be the same. Multiply negative, actually just negative 16 on the top equation. And the second equation, multiply d minus 2. I will treat the operation d as a constant. So I just multiply d minus 2 at the bottom. Do that, I will get negative 16 d minus 2x. If we just remove that for now. Minus 16 y equal to 0. And then we have 16 d minus 2x plus d minus 2 square y equal to 0. D minus 2 y of 0. This is just derivative of 0, and then 2 times 0, which is, of course, 0. Right. And then we'll add side by side. The x we got eliminate, and then we'll just solve for y. So we will have negative 16y plus d minus 2 square y equal to 0. And this one, if we rewrite as negative 16y, the d minus 2 square I can write as d square minus 4d plus 4 y equal to 0. Multiply it out. I multiply it out and simplify. I should have, let's just say that is our problem. I need more space. So we will have negative 16y plus second derivative minus 4 times derivative plus 4 times the function. Let's move that down. just write that a little bit lower. So negative 16y plus second derivative minus 4 times derivative plus 4 times the function equal to 0. Now to simplify this, we have second derivative minus 4 times derivative minus 12 times the function equal to 0. Alright, that is simple enough. We have homogeneous equation with constant coefficient. So we solve for that. Auxiliary equation r squared minus 4r minus 12 is equal to 0. So factor out r minus 6, r plus 2 is 0. So r is negative 2 and r 6. So we will have the solution y equal to c1 e to the 6r 6t plus c2 e to the negative 2t. Right. So that is our first solution. I mean, this is solution for y. Now we're going to solve for x. Right. There's a few ways to solve for x. We can eliminate x. We eliminate x to solve for y, and then of course we eliminate y to solve for x. But if we do that, the constant is going to be a little bit different. So what we do is we look at the original problem, meaning this system of equation. If we look at this system of equation, we see that on the top equation we have x on two different places. That's not a good thing to substitute. That's not a good equation to solve for x. If we solve for x, we have to still have derivative of x, which is a differential equation. So that is not a good idea to substitute into the first equation. Now if we substitute y into the second equation, we can substitute here and here. We only have one x in one place. And to solve for that x, it will be a lot easier to do. So I'm going to substitute into second equation. Right. Now first, I do have y equal to that. So we keep that. And then we check the second take derivative to find y prime. Because in the equation where we substitute back into solve for x, we do have derivative and the function. Right. So we have derivative of y is equal to 6 c1 e to the 6t minus 2 c2 e to the negative 2t. Right. Then we substitute into the equation that we have in the box. So we substitute into this equation y prime equal to 2y minus 16x. By the way, let's just solve for x here, and the substitution will be a lot easier. So if we solve for x, we have, let's move 16x on the left side, and we have 2y minus y prime. And if we solve for x, x will be 1 over 16 2y minus y prime. That is a lot easier to substitute in. So we're going to have x equal to 1 over 16. The function y, we have this one, c1 e to 60 plus c2 e to the negative 2t. So that is the function y. And now we'll take derivative. The derivative is going to be this. And don't forget we have, it is minus. Right. I did forget that there's a 2 in front of y. So let's multiply this by 2. c1 e to the 60, and we multiply by 2, c2 e to the negative 2t. Right. And then subtract the derivative in the purple box. We will have minus 6 c1 e to the 60, and then we minus a negative. It's going to be a plus 2 c2 e to the negative 60. And then multiply it out and simplify. We should have x equal to combine like terms. We have 2 here, a minus 4 here, 2 and a minus 4. 2 and minus 6 is minus 4, divided by 16, so we have negative 1 over 4, c1 e to the 60, and we have 4 c2 divided by 16, so we have 1 over 4 c2. This should be a 2t, just a typo. I'm sorry, a mistake in this box. So 1 4 c2 e to the negative 2t. And so that's what we have. Don't have the parentheses here. So x is equal to this, and y, this is x, and that is y. And so that's what we have for this problem.